Hi, my name is Basir. In this video, we'll be working on exercise 11.1 from Telangana State Syllabus. Before we start working on exercise questions, let me show you a few of the basics that would help us in solving the problems from exercise 11.3, 11.4. Let me quickly go ahead and take a new worksheet here. Okay, so there are three trigonometric identities in trigonometry. The first one is sine square theta plus cos square theta is 1, secant square theta minus tan square theta is equal to 1, cosecant square theta minus cot square theta is equal to 1. So we have three trigonometric identities. Sine square theta plus cos square theta is 1, secant square theta minus tan square theta is 1, cosecant square theta minus cot square theta is equal to 1. I don't want to go ahead and prove these three identities for you. We'll just readily make use of these three trigonometric identities in solving exercise 11.1 questions, 11.4 questions. I have told you previously we have a set of 6 trigonometric ratios, right? Sine theta, cos theta, tan theta, cosecant theta, secant theta, and cot theta. So we have a set of 6 trigonometric ratios: sine theta, cos theta, tan theta, cosecant theta, secant theta, and cot theta. Every other trigonometric ratio we can write it in the form of sine or cos. For an example, tan theta we can write it as sine theta by cos theta. Cosecant theta we can write it as 1 by sine theta. Secant theta we can write it as 1 by cos theta. Because cosecant is reciprocal of sine, cos is reciprocal of secant, cot is reciprocal of tan. Now tan is sine by cos, so reciprocal of sine by cos is cos by sine. So cot theta I can write it as cos theta by sine theta. So you see here we can write every trigonometric ratio, every other trigonometric ratio in the form of either sine or cos, right? And out of these 6 trigonometric ratios we have a set of 3 trigonometric identities. Sine square theta plus cos square theta is 1, secant square theta minus tan square theta is 1, cosecant square theta minus cot square theta is 1. If you just know how to write trigonometric ratios in the form of sine and cos, and if you know these 3 trigonometric identities, you are good to work on exercise 11.4 problems. So let us start working on exercise 11.4 problems now. The first question says, evaluate the following. First bit, 1 plus tan theta plus secant theta into 1 plus cot theta minus cosecant theta. In this exercise I'll mostly cover almost all the questions, because I see that every other question is different. Every question is different from one another. So I'll pretty much work on all the problems in this video. So the first question says, ask us to evaluate 1 plus tan theta plus secant theta into 1 plus cot theta minus cosecant theta. Let me go ahead and write down this question. 1 plus tan theta plus secant theta into 1 plus cot theta minus cosecant theta. Now I have told you we either make use of trigonometric identities or else we convert each trigonometric ratio in the form of sine or cos. Tan we can write it in the form of tan, we can write it as sine by cos, right? Tan theta is sine theta by cos theta. Cosecant is reciprocal of cos, so I can write secant theta is reciprocal of cos theta, so I can write secant theta as 1 by cos theta. Cot, I can write it as cos theta by sin theta, and cosecant theta I can write it as 1 by sin theta. So all these trigonometric ratios I have converted them in the form of sine and cos. Now let me take LCM of this, and the LCM is cos theta. So what is what do I get here? Cos theta plus sin theta plus 1 into I'll again take the LCM here. LCM is sin theta, so what do I get here? Sin theta plus cos theta minus 1. Let us just reconsider this thing here. This is sin theta plus cos theta. This is also sin theta plus cos theta. Now this is 1, this is 1. The only difference that we get is here we have plus, here we have minus. So this is in the form of a plus b into a minus b, which is a square minus b square. A plus b into a minus b is what? A square minus b square. So this is a plus b, this is a minus b. So a plus b into a minus b should be a square minus b square. By cos theta into sin theta I am writing as it is. Now what is this? This is in the form of a plus b whole square. What is a plus b whole square? A plus b whole square is a square plus b square plus 2ab. A plus b whole square is a square plus b square plus 2ab. So let me expand sin theta plus cos theta whole square. It should be sin square theta plus cos square theta plus 2 sin theta cos theta minus 1 square is how much? 1 by this I am writing as it is. I am just rearranging sin theta cos theta, I am writing it as it is. Now sin square theta plus cos square theta, this should be equal to 1 because we know this is a trigonometric identity. Sin square theta plus cos square theta is equal to 1. So in place of sin square theta plus cos square theta I am going to write 1. 2 sin theta cos theta minus 1 I am writing as it is by 2 sin theta cos theta. Plus 1 minus 1 gets cancelled. Now below we just have sin theta cos theta, right? So this sin theta cos theta, this sin theta cos theta gets cancelled, and what we get here? We get 2 as the answer. Let us go ahead and work on the second problem now. So this is our second bit that says sin theta, that is asking us to evaluate sin theta plus cos theta whole square plus sin theta minus cos theta whole square. Let's see. Sin theta plus cos theta whole square plus sin theta minus cos theta whole square. That's the question. Now this is in the form of a plus b whole square, right? A plus b whole square, and this is also in the form of a minus b whole square. So I'll have to expand it. Let me make use of a plus b whole square formula. What is a plus b whole square? A square plus b square plus 2ab, and this is in the form of a minus b whole square. What is a minus b whole square? A minus b whole square is a square plus b square minus 2ab, right? Now we know that this is a trigonometric identity. Sin square theta plus cos square theta should be 1, and this 2 sin theta cos theta, this 2 sin theta cos theta, I'm just going ahead and cancelling them because this is plus 2 sin theta cos theta, this minus 2 sin theta cos theta gets cancelled. Now sin square theta plus cos square theta I got it as 1, and this sin square theta plus cos square theta I get it as 1. 1 plus 1 is how much? 2. Let us go ahead and work on the third bit now. The third bit says us to evaluate the value of secant square theta minus 1 into cosecant square theta minus 1. cosecant square theta minus 1, cosecant square theta minus 1. Simple. We'll just convert secant into in the form of sine or cos. I can write secant square theta is as 1 by cos square theta, because secant is reciprocal of cos. Secant theta I can write it as 1 by cos theta, right? So secant square theta would be 1 by cos square theta. Cosecant, it is reciprocal of sine, so cosecant square theta I can write it as 1 by sine square theta. Now we'll just take LCM. Cos square theta, 1 minus cos square theta by cos square theta into 1 minus sine square theta by sine square theta, right? So this cos square theta, it multiplies here and then it divides. 1 minus cos square theta into 1 is cos square theta, 1 minus cos square theta by cos square theta. Similarly, 1 minus sine square theta by sine square theta. We know that this is a trigonometric identity. Sine square theta plus cos square theta is 1. So if I take plus cos square theta to the right hand side, I'll end up getting this. Plus cos square theta, if I take to the right hand side, I get minus cos square theta, which means sine square theta is 1 minus cos square theta. So in place of 1 minus cos square theta, I can write it as sine square theta by cos square theta as it is. In the same way, 1 minus sine square theta will be cos square theta. Why? Because if I just keep sine square theta, if I remove sine square theta plus from here, from the left hand side, if I take sine square theta to the right hand side, it becomes like this. Cos square theta is 1 minus sine square theta. So in place of 1 minus sine square theta, I can write it as cos square theta. So you just have to remember, 1 minus sine square theta is cos square, 1 minus cos square theta is sine square theta, 1 minus sine square theta is cos square theta. Sine square theta gets cancelled, cos square theta get cancelled, and I get the answer as 1. Let us check the other bit here. Okay, so we have the second question. Show that cosecant theta minus cot theta whole square is equal to 1 minus cos theta by 1 plus cos theta. ठीक है. So the question is cosecant theta minus cot theta whole square. I'll have to show it as 1 minus cos theta by 1 plus cos theta. So I told you in the very beginning itself, we have to convert all trigonometric ratios in the form of either sine theta or cos theta. So cosecant theta, I can write it as 1 by sine theta, right? Cot theta, I can write it as cos theta by sine theta. Whole square I'm writing as it is. LCM, what is the LCM? Denominator is sine theta here also and then here also. So the LCM will be sine theta. I'm writing the numerators as it is, 1 minus cos theta whole square. Now this square, it goes for the numerator also and it goes for the denominator also. So this square, it goes for the numerator, which is 1 minus cos theta, 1 minus cos theta whole square, and this square goes for the denominator also, so sine square theta, right? Now 1 minus cos theta whole square, so I can write 1 minus cos theta 2 times, right? I believe you must be knowing this. A square, I can write it as a into a, right? So in the same way, 1 minus cos theta whole square, I can write it as 1 minus cos theta into 1 minus cos theta. Sine square theta, I can write it as 1 minus cos square theta. We have seen this a while ago. We know that this is a trigonometric identity. Sine square theta plus cos square theta is 1. So plus cos square theta, if I take to the right hand side, I end up getting this. Sine square theta is 1 minus cos square theta, right? So in place of 1 minus cos square theta, I can write it as sine square theta. Or else let's just do this. I'll just check the question once more. So we have to prove this, right? 1 minus cos theta, we have to prove that cosecant theta minus cot theta whole square is 1 minus cos theta by 1 plus cos theta. Okay, so we'll just keep this as cos theta only then. No need to convert this in the form of sine, because in the question we need the answer in the form of cos theta. So I'll just keep it like that only. I'll pretty much do it this way. 1, I can write it as 1 square, right? 1 square is 1 only. Numerator I'm writing as it is. Now denominator is in the form of a square minus b square, right? a square minus b square, and we know that a square minus b square is a plus b into a minus b, right? So I can write it as a plus b into a minus b form. This is a square minus b square. I can write it as a plus b into a minus b. 1 minus cos theta, 1 minus cos theta gets cancelled. I end up getting the answer as 1 minus cos theta by 1 plus cos theta. And this is what they wanted us to prove, right? Okay, we'll go ahead and work on the third one now. Show that square root of 1 plus sine a by 1 minus sine a is equal to secant a plus tan a. This is pretty simple. So the question is square root of 1 plus sine a by 1 minus sine a. We'll have to show that this thing is equal to secant a plus tan a, right? Okay, let's start working on this. This is pretty simple. 1 plus sine a by 1 minus sine a. You just have to remember the denominator is 1 minus sine a, so I'll have to multiply and divide by 1 plus sine a. The denominator is 1 minus sine a, so I will have to multiply and divide by 1 plus sine a. If the denominator would have been 1 plus sine a, I would have multiplied by 1 minus sine a. We just have to change the sign and multiply. So the sign here is minus, I'll change it to plus, so it becomes 1 plus sine a. I'll multiply and divide by 1 plus sine a, as simple as that. Now 1 plus sine a into 1 plus sine a is 1 plus sine a whole square. As similar as this one, a into a is a square, so I can write 1 plus sine a into 1 plus sine a. I can write it as 1 plus sine a whole square. Because 1 plus sine a is repeating twice, I can write it as whole square, right? By this becomes, this is in the form of a formula, a minus b into a plus b. Denominator is in the form of a formula, a plus b into a minus b is how much? Is what? A square minus b square, right? So numerator I'm writing as it is 1 plus sine a whole square by 1 square is 1 only, this 1 square is 1 only, 1 minus sine square a, 1 plus sine a whole square by 1 minus sine square a. I can write it as cos square a, because I know that this is a trigonometric identity. Sine square a plus cos square a is 1, so I'll just write it down here. I know that sine square a plus cos square a is 1, plus sine square a, if I take it to the right hand side, it becomes minus sine square a. So 1 minus sine square a is how much? It is cos square a. So in place of 1 minus sine square a, I'm writing cos square a, right? Now numerator it has square, denominator also it has square, so I can take it as whole square. So I'll just write it down like this, 1 plus sine a by cos a whole square. Square and square root gets cancelled. I get 1 by sine a, 1 plus sine a by cos a, and this denominator cos I can distribute it. So this cos, it gets distributed like this, 1 by cos a plus sine a by cos a, right? This cos, it divides 1 also, it divides sine also. 1 by cos is secant a, sine by cos is what? Tan. So we get the value answer as secant a plus tan a, and that is what they wanted us to prove, right? Let us go ahead and work on the other one. What's the other thing here? Take a fourth one. Show that 1 minus tan square a by cot square a minus 1 is equal to tan square a. Okay, let's go ahead and prove this. Fourth one, 1 minus tan square a, 1 minus tan square a by cot square a minus 1. I'll have to show that this is equal to tan square a, right? Okay, take it. I've told you in the very beginning itself that we have to convert all the trigonometric ratios in the form of either sine or cos. So I'll convert this in the form of sine and cos. Tan A. Tan, I know that I can write it as sine by cos, right? We know that tan A is sine A by cos A. So tan square A, I can write it as sine square A by cos square A. Cot. Cot is cos square A by sine square A. Minus 1 I am writing as it is. Now I'll just cross multiply this. Cos square A minus sine square A by cos square A. So this cos square A multiplies and then it divides. Cos square A one's a cos square A minus sine square A by cos square A. And this also just as similar as this one. Sine square A into 1 is sine square A by sine square A. Now this is my numerator, this complete thing is my numerator, and this complete thing is my denominator. Okay, so I'm writing the numerator as it is, cos square A minus sine square A by cos square A. This denominator, if I take it above, it becomes reciprocal. So cos square A minus sine square A by sine square A will become sine square A by cos square A minus sine square A. This and this gets cancelled. I end up getting sine square A by cos square A. And I know that sine by cos is what? Tan. So sine square A by cos square A is what? Tan square A. And this is what we wanted to prove, right? Let us go ahead and work on fifth problem. Show that 1 by cos theta minus cos theta is equal to tan theta into sin theta. ठीक है. Show that 1 by cos theta minus cos theta is equal to tan theta into sin theta, right? ठीक है, we'll just cross multiply. I'll just take the LCM of this left hand side. Cos theta into cos theta is how much? Cos square theta. By cos theta I am writing as it is. 1 minus cos square theta is what? Sin square theta. 1 minus cos square theta is sin square theta because it's a trigonometric identity. Sin square theta, can't I write it as sin theta into sin theta? By cos theta I am writing as it is. Sin by cos is how much? Tan. Sin into sin theta I am writing as it is. So I got the answer. Tan theta into sin theta. Let's go ahead and work on the next one. The next one is sixth problem, which is asking us to simplify secant A into 1 minus sin A into secant A plus tan A. Okay, we can do it in two ways. We can actually do it in do this in two ways. I can just instead of doing it in two ways, I'll just use the same concept that I've been explaining you so far. I'll just convert every other trigonometric ratio in the form of either sin theta or cos theta. In solving this problem, I can actually make use of secant square theta minus tan square theta is equal to 1 identity also. But instead of that, I'll just stick to one basic concept which we were using for all these problems. We'll convert every trigonometric ratio in the form of either sin theta or cos theta. Okay. So secant A, I can write it as 1 by cos A, right? This is already in the form of sin. I'm writing it as it is. Secant, I can write it as 1 by cos. Tan, I can write tan as sin by cos. So I'm writing all the trigonometric ratios in the form of sin and cos. So now in the second step, if you see, all the trigonometric ratios are in the form of either sin or cos. ठीक है. 1 by cos A into 1 minus sin A. This, let me take the LCM. cos A and cos A, LCM would be cos A only, right? And the numerator I have 1 plus sine A, 1 plus sine A. Now this becomes a formula, 1 minus sine A into 1 plus sine A. This is in the form of A plus B into A minus B. It should be A square minus B square, because we know that A plus B into A minus B is A square minus B square. Cos A into cos A is cos square A, right? 1 square is 1 only, so I'm getting it like this, 1 minus sine square A by cos square A. 1 minus sine square A is cos square A by cos square A as it is. Cos square A gets cancelled. I get the value as 1. Let us go ahead and work on the 7th one now. Prove that sine A plus cosecant A whole square plus cos A plus secant A whole square is equal to 7 plus tan square A plus cot square A. Okay, let us go ahead and prove this. Oh my goodness, what's the question again? Sine A plus cosecant A whole square plus cos A plus secant A whole square. I have to prove that this is equal to 7 plus tan square A plus cot square A. Okay. See, this is quite simple. We will just expand this first. Sine A plus cosecant A whole square. This is in the form of A plus B whole square. What is A plus B whole square? A square plus B square plus 2AB, right? Again, this is in the form of A plus B whole square, cos A plus secant A whole square. I'll expand it using A plus B whole square formula. Again, A plus B whole square is A square plus B square plus 2AB, right? Let me just go ahead and rearrange it, or else I can just think of it this way. Sine square A plus cos square A. Sine square A plus cos square A is 1. ठीक है. Let me write this. Okay, in the if you see on the right hand side, you should get the answer in terms of tan and cot, not in the form of cosecant or secant, right? So cosecant square A, I can convert it in the form of cot square A, right? Cosecant square A is 1 plus cot square A. Why and how? ठीक है, I'll show that to you. We know that cosecant square A minus cot square A is 1. That's a trigonometric identity. Cosecant square A minus cot square A is 1. If I remove minus cot square A from the left hand side, then I'll have this minus cot square A. If it goes to the right hand side, it becomes plus cot square A. So cosecant square A is 1 plus cot square A. So in place of this cosecant square A, I can write 1 plus cot square A. Right, as simple as that. Let me just go ahead and erase this. Okay, so I've shown you how we can write cosecant square A as 1 plus cot square A just by using the trigonometric identity. Cosecant square A minus cot square A is equal to 1. 2 sine A into cosecant A, I can write it as 1 by sine A, right? Everybody knows that cosecant is reciprocal of sine. So cosecant A, I can write it as 1 by sine A. Secant square A, I can write it as 1 plus tan square A, because again, use the trigonometric identity. Secant square A minus tan square A is equal to 1. Minus tan square A, if I take it to the right hand side, it becomes plus tan square A. So secant square A is 1 plus tan square A. So in place of secant square A, I am writing 1 plus tan square A plus 2 cos A into secant. Secant A, I can write it as 1 by cos A, because secant is reciprocal of cos, right? This sign gets cancelled, this cos gets cancelled. So what I'm getting here, 1 plus cot square A plus 2 plus 1 plus tan square a plus 2, right? Now add this numericals, 1 2 2 plus 2 4 5 6 7. So I get 7 plus tan square a plus this is cot square a. So I get the answer as 7 plus tan square a plus cot square a. That is what we had to prove. Okay, we'll go ahead and work on the rest of. Well, even this problem we can work it and we can solve this in two ways, but I'll stick to one basic way that I've been teaching you all this while. We'll convert every other trigonometric ratio in the form of either sine theta or cos theta. ठीक है. This is 1 minus cos theta into 1 minus sine theta. So this is in the form of a minus b into a plus b, which is a square minus b square. This cot theta I can write it as cos square theta by sine square theta, right? Cot square theta is cos square theta by sine square theta. 1 square is 1 minus cos square theta into this. I can just multiply it here this way. Sine square theta into 1 is sine square theta plus cos square theta by sine square theta. 1 minus cos square theta, I know that 1 minus cos square theta is sine square theta. Sine square theta plus 1, this is an identity. Sine square theta plus 1 is how much? Sine square theta plus cos square theta is how much? 1 by sine square theta. I'm writing as it is. Sine square theta gets cancelled. I get the value as 1. If secant theta plus tan theta is equal to p, then what is the value of secant theta minus tan theta? Okay, so here it says secant theta plus tan theta is equal to p. It is asking us to find out what is the value of secant theta minus tan theta. We know that we have a trigonometric identity, secant square theta minus tan square theta is equal to 1. Now what, this is in the form of formula, right? A square minus b square. What is a square minus b square? It is a plus b into a minus b. Secant theta plus tan theta is given as p. So in place of secant theta plus tan here, okay, here we have it. Secant theta plus tan theta. In place of secant theta plus tan theta, I can write it as p. This secant theta minus tan theta I am writing as it is equal to 1. So secant theta minus tan theta will be 1. P is multiplying on the left hand side, so p will divide on the right hand side. So secant theta minus tan theta is 1 by p. It gave us the value of secant theta plus tan theta. It wanted us to find out the value of secant theta minus tan theta, and we found it out. If secant theta plus tan theta is p, secant theta minus tan theta is 1 by p. See, this is pretty simple. At times they ask you like this: secant theta plus tan theta is 2, then what is secant theta minus tan theta? It is 1 by 2. If secant theta plus tan theta is 5, secant theta minus tan theta is 1 by 5, right? Okay, let me go ahead and work on the last problem from this exercise. I'll go ahead and select a new worksheet for this because I believe it will take a little space for me to solve this problem. 10th problem. So 10th problem says cosecant theta plus cot theta is k. Then prove that cos theta is equal to k square minus 1 by k square plus 1. ठीक है, cosecant theta plus cot theta is equal to k. This is what is given. They want us to prove that cos theta is k square minus 1 by k square plus 1. See, this is pretty simple. All we have to do is we have to make use of this trigonometric identity. Cosecant square theta minus cot square theta is 1. Again, this is in the form of a square minus b square. What is a square minus b square? It is a plus b into a minus b, right? Now cosecant theta plus cot theta value is given as k. So in place of cosecant theta plus cot theta, I'll write k. Everything else I'm writing as it is. So cosecant theta, oh my god, my handwriting is too bad on this graphics tablet. In reality it is not actually. So cosecant theta minus cot theta is 1 by k. So I have these two equations here. Cosecant theta plus cot theta was given as k, and I got cosecant theta minus cot theta as 1 by k. Now what we have to do is we have to add these two equations first and then subtract these two equations. So once we have to add those two equations, second time we'll have to subtract those two equations. Let us do it here. It's quite simple. 1 plus 2. I'm adding those two equations first. Cosecant theta plus cot theta, it is k. That's the first equation. Cosecant theta minus cot theta is 1 by k. So first time I'm just adding those two equations. When I add plus cot theta minus cot theta, they get cancelled. Cosecant theta plus cosecant theta is how much? Cosecant theta plus cosecant theta is 2 cosecant theta. This is k plus 1 by k. K plus 1 by k. So 2 cosecant theta is k into k. How do I add this k and 1 by k? I can just multiply it this way, right? K into k is what? K square plus 1 as it is by k. Cosecant theta, oh my goodness, let me just try to write it a bit slow here. K square plus 1. 2 is multiplying, so 2 will divide on the right hand side. So I end up getting like this. Cosecant theta is equal to k square plus 1 by 2k. So once I have added these two equations, first and second equation, I have added it first here. Now I'll subtract those two equations. 1 and 2 I'm going to subtract now. Once I've added those two equations, second time I'm going to subtract those two equations. What is the first equation? Cosecant theta plus cot theta is k. So cosecant theta minus cot theta will be 1 by k. I'm subtracting these two equations now. When I subtract these two equations, the sign will change. This becomes minus, this becomes plus, and this becomes minus. So plus cosecant theta minus cosecant theta, it gets cancelled. Cot theta plus cot theta is 2 cot theta. This is k and this is minus 1 by k. K minus 1 by k, right? So 2 cot theta is equal to k into k is k square minus 1 by k. Cot theta is equal to k square minus 1 by 2 is multiplying, so 2 will divide here on the right hand side. So I got these two things. Let me name it as 3 and let me name it as 4. At last, divide 4 by 3. So what's the fourth equation? Cot theta is equal to k square minus 1 by 2k. And what's the third one? Cosecant theta is equal to k square plus 1 by 2k. We know that cot theta we can write it as cos theta by sin theta. And cosecant we can write it as 1 by sine. This 2k and this 2k gets cancelled. Right hand side I'm getting k square minus 1 by k square plus 1. This sin theta and this sin theta gets cancelled. I end up getting cos theta as k square minus 1 by k square plus 1. And this is what they wanted us to prove. See here, cos theta is equal to k square minus 1 by k square plus 1. So this is what they wanted us to prove. We are done with the complete chapter, Trigonometry chapter 11 from Telangana State Syllabus. I hope you have learned something, at least something from these videos. If you have any difficulties, if you still experience any difficulties, then feel free to post your questions as comments on YouTube, and I'll read those comments and I'll get back to you. So until next time, goodbye.